All right, welcome to the Explainer. Today we are going deep underground to uncover the hidden math that, believe it or not, keeps our cities from flooding every time it rains. You know the scene, right? Streets turning into rivers, manholes just bubbling over after a big storm. It looks like total chaos. But the reason it happens, and maybe more importantly, why it doesn't happen every single time, well, that's where things get really interesting. It's a huge engineering puzzle. So to really wrap our heads around this, I want you to picture the city's entire wastewater system as a giant two-headed dragon. Seriously. Each head is a totally different kind of problem, and somehow engineers have to build one single system of pipes to battle them both at the same time. Okay, let's start with the first head. This is the predictable beast, the one engineers have a pretty good handle on. It's simply the water that we all use every single day. This stuff has a name, of course: sanitary sewage. You know, it's all the water coming from our showers, sinks, toilets, all our homes and businesses. It's that constant day in, day out flow. So just how much water are we talking about here? Well, engineers have this fantastic rule of thumb. They figure that about 80%, 80% of all the clean water a city pumps into our homes and businesses comes right back out as sewage. But, and this is key, that flow isn't just a steady trickle. Nope. Just like the highways above ground, the pipes below ground have rush hours. Just think about it. The morning, right? Everyone's showering, flushing, getting ready for the day pretty much all at once. And you can really see that difference here. That peak morning flow can be 2, maybe even 3 times higher than the daily average. So the pipes, they have to be big enough to handle that massive morning surge. If they're not, well, that's when things start backing up. Okay, so that was the predictable beast. Now let's talk about the second head of the dragon. And this one is a whole different animal. It's not predictable, it's not steady, and man, is it powerful. We are talking about storm runoff. When it rains, a huge amount of that water doesn't just soak into the ground. Instead, it hits hard surfaces like roads, parking lots, and roofs and just rushes off. This isn't some gentle trickle, folks. It's a sudden, violent flood hitting the system all at once. But what's really cool is that the math behind this monster is actually pretty elegant. To figure out just how big it's going to be, engineers really only need to know 2 simple things: how hard it's raining and what kind of surface that rain is landing on. Basically, how spongy it is. And that sponginess actually has a technical name. It's called the runoff coefficient. Think about it like this. A grassy lawn, it's like a sponge. It soaks up most of the rain, so maybe only 15% actually runs off. But an asphalt parking lot, totally different story. It's slick. It sheds almost all of it. We're talking a whopping 85% becoming instant runoff. So here's how they put it all together. They take the intensity of a storm, and they often use a model for this, like a really heavy downpour you'd only expect to see once every, say, 10 years. They multiply that by the area of all the different surfaces in a neighborhood, each with its own runoff number. And boom, that gives you the total size of the monster they have to prepare for. And this is where we get to the real genius of this whole thing, especially in cities with what they call combined sewer systems. They have to design one single network of pipes that can handle both of these beasts at the exact same time, that predictable daily trickle and the sudden raging monster flood. I mean, that's the core challenge, isn't it? The entire system has to be built for the absolute worst-case scenario. Because if it's not, the dragon wins, and the city floods. It's that simple. Let's try to picture this. So first up, here's our predictable beast again. That's the daily sewage flow, remember, with its little morning rush hour. This is the baseline, what the system deals with day in and day out, no problem. Okay, but now watch what happens when a big storm hits. That sudden monster, the storm runoff, it just completely dwarfs the normal daily flow. You can see it right there. Our predictable little beast becomes a tiny, tiny fraction of what's gushing through the pipes. Just to put a number on it, during a major storm, all that water from our homes and businesses, it might only be about 5% of the total flow. The other 95%, that's just pure rainwater, the runoff monster. So when it's all said and done, the final design is basically just simple addition. You figure out the peak flow from the predictable daily stuff. Then you calculate the massive flow from that big monster storm. You add them together, and that final number tells you exactly how big your pipes need to be. So you might be thinking, why does this matter so much? Why is getting this math exactly right so absolutely critical for, just keeping our cities running? Well, I love this way of putting it. This isn't just about pipes and numbers. The math of wastewater is like an invisible shield. It's this unseen system that is quietly protecting us from disaster every single day. A shield we all rely on, whether we know it or not. Because think about what happens if that math is wrong. If the pipes are just a little too small, the consequences are, well, they're awful. We're talking street flooding, expensive property damage, and the absolute nightmare scenario, raw sewage backing up into people's basements. That's a huge public health crisis waiting to happen. So, at the end of the day, this elegant math, this taming of the two-headed dragon, it's one of the cornerstones of modern city life. It's the hidden logic that lets millions of us live packed together without being totally overwhelmed by our own waste and by a simple rainstorm. And that leaves us with one final and pretty urgent question. You see, this math has worked for decades, but it was all based on historical weather patterns. Now, as our climate changes, storms are getting stronger and more frequent. That sudden monster is getting bigger. So the big question we all have to ask is, are the equations, and more importantly, are the pipes that protect our cities still big enough to handle what's coming?